Thank you all for joining today's webinar hosted by Invest Puerto Rico. We are excited to be pulling together some of the top experts in America actually about smart energy. Today's actually going to be a really great session, especially because we just had the unfortunate outage in Texas and people realized how important energy is, how important investment in energy is. Really, as we go to the future of 5G and smart cities, it becomes even more important to have energy that's reliable, that is green, that is able to support industrial needs, and as we saw in Texas, be able to support hospitals and other mission critical systems. The panel today is truly world-class. We have gone the extra mile to pull together the actual developers. So through this session today, you're actually going to meet people who are actually designing and inventing the systems, people who actually work on the front lines of supporting our nation. So it is a truly fantastic session. Our sponsor for this event is Gail Nolan. Gail is well known in terms of her work in economic development across multiple states. She's worked with multiple White House administrations. She's a true national asset. What I'd like to do with this session today is actually introduce Gail and have her say some opening remarks on the importance of the session and themes you're going to see throughout today, which is in terms of the importance of energy, the importance of making sure that as we develop these energy solutions, they're actually not done in isolation. They're done in cooperation, in coordination with state agencies, with manufacturers, with universities, so that the university kids get trained for the right jobs, work with product designers so that the smart energy products we need are in the pipeline. So with that, I'll introduce our host, our sponsor of the event, Gail. Gail, thanks for being our sponsor. Thanks for pulling together today. Would love to hear a little bit about, first, your background in economic development, and then really the kind of state-of-the-art work you're doing in Puerto Rico and what we expect to hear this afternoon on the East Coast.
Great. Well, thank you, Junaid. Really honored. This is a great lineup of really impressive and intelligent people who are aligning towards problem solving, which all of you know, that's really what technology does. Technology isn't a thing on its own. It's creating solutions. And I also want to say, Invest Puerto Rico as a sponsor, I'm honored to be the representative from the organization. And my particular role, my background is in economic development, specifically in disaster recovery and global competitiveness. And at Invest Puerto Rico, I'm the Chief Strategy Officer, which is about product improvement. So the product being the island of Puerto Rico, from the viewpoint of companies that would want to do business here and be successful. And so all the things that we put together are from that lens of making sure that they can, that as they make a decision to move to the island because the assets on the island match their needs as a company, and that as a result of that great relationship that of all of the assets that are required, they're incredibly successful. So the next slide, I'm going to go forward to the next slide, it kind of setting the stage for all of the other people that are going to talk throughout the course of this webinar. So first of all, we're all familiar with Puerto Rico and the energy situation post-Maria, where a lot of the images that hit the television and the newsstand was of an island that was completely dark, and knowledge that in some areas the power was out for months. I'm going to add, though, that while those made sensational headlines, wasn't necessarily true. There was significant business continuity. I know of businesses on the island in the, for example, in the pharmaceutical industry that said that they only had one delayed shipment through all of that. So there were things that were working and things that were not working, but it did highlight the idea that some of these structures, as they're built on over time, don't match some of the assets that are available right now. And so because of the tremendous devastation, and you mentioned Texas, and a lot of people think of Puerto Rico from a hurricane perspective, but that particular event was really like a 100-year event, even longer in terms of how NOAA classifies those. That's not standard for the island. Just like Texas gets snow, frequently, they just don't get it to the level that they did in the last couple of weeks. So from that mindset, though, it really brings up the thought that there are better ways to build these systems. And in fact, the slogan on the island of Puerto Rico became "Build Back Better." So in other words, you're not trying to get back to where you were before. You're recognizing that this moment in time is an opportunity to really become a global and national model. So that the next slide then, from that perspective. So looking at this as an opportunity for the island, the first question is, in the last 3 years, what really has changed on the island that from some of those earlier reports? There's an independent regulator, and looking again at Texas, we know that there's a really complex combination of regulated and unregulated and public and private. That's a really important component of having a really functional and long-lasting grid. And so Puerto Rico really has done a lot of work in the last 3 years in terms of identifying where that right balance is. And so we're, despite some of the setbacks, we're actually farther ahead of many places in the country, in fact, many places globally, in terms of framing what a new and completely modernized grid would look like. There is a significant amount of federal funding for a new grid. About $9 billion, I think, of that will go towards the transmission side of the equation. And then there's really this transition to diverse generation of power. So how do you look at the different sources of energy and create redundancy by not picking one, but having this network of different ways of generating energy to, again, support that redundancy. On the island of Puerto Rico, the reason why the island is a really interesting, I kind of call it like a blank canvas. It's really a good demonstration model location because there's a lot of complexity on the island. So there's complexity of management in this system. So the interconnectivity of the regulator, the new grid, newly brought online generation units and managers is something that's going to have a really well-defined structure in order to make sure that all of those needs are served, and that you don't put together partners and then end up with greater problems because you haven't thought through some of the challenges of that interconnectivity. There's varied Wi-Fi environments on the island, and that's kind of related to the next bullet down, which is a very varied terrain. And so, how those transmission elements of interconnecting these different types of generation services and grids and microgrids is going to have to be figured out on an island where there are quite literally 6 different and unique microclimates. And so, that helps us to use the island for, no matter where in the country this kind of solution is going to be deployed. And then finally, there's differing economies on the island. Puerto Rico has a centralized government, but there's a lot of strength and independence within municipalities throughout the island. And so each of them has a different approach, and interfacing all of those and connecting them all together to one unified but segregated system is going to be something that, again, will be a great demonstration for the rest of the country. The important thing as we look at this is to remember is that technology is the management tool that all of us are talking about on this webinar, and the rebuilding of the grid with smart management isn't just a dream or a vision. It's the only way it's going to happen, and happen in a way that can be managed appropriately and sustainably. And this is really consistent with what a lot of us in the profession of economic development know, and that's that technology is the absolute driver of economic stability. And so by partnering those two things on the island of Puerto Rico, we believe that we're creating an ecosystem that isn't just looking at rebuilding the island to what it was or what it has been historically, but it's really creating a new paradigm on the island that makes it, you know, a very forward-thinking economy and destination. Next slide. So kind of under that future vision, the idea is to use the PR5G Zone as an accelerator to really tackle some cost-effective solutions that industries are facing. And within that, it's leveraging some of these challenges onto an island that has a lot of opportunity. So it's just a perspective of how you see these things. We also had this partnership that we're developing between Invest Puerto Rico and the new 5G zone as an independent not-for-profit is really important. So Invest Puerto Rico is a marketing attraction agency for the island, and we're tasked with bringing new business to the island, and not just to bring new business to the island, but to bring new business to the island that lines up with what our assets are and that can be successful on the island. I'm repeating that really important thing. And the 5G zone is aligned to that mission in that there will be three components to it. And the first will be looking at these really smart people that you'll see on the rest of this webinar, aggregating them into a coalition that starts to problem solve and come up with innovative solutions, and then exposing either personnel at companies or academic students at the local universities, exposing them to those new innovations so that they can build those into their knowledge base as part of the workforce that will manage these smart innovation solutions. And then the third part is giving access to business to be able to plug into this computational capability that this network provides and use that to power redundantly through the different regions that are connected through this Labs Across America projects.
As we transition to our next speaker, Jose, I had one question for you that I think is kind of topical. A lot of people have criticized these smart energy projects as wasting money. And I think one of the things you've worked hard on is to make sure that these are actually great businesses, that these are actually help America actually reduce the cost of energy. It would be great for you to make a comment on that, because that is, you know, when you use the word smart energy, people use the word pork barrel giveaways or whatever. And in fact, it's quite the opposite. You've spent a lot of time on making sure this is an economic win for the federal government, for the state government, for companies. Could you just make a comment on that?
Sure, if I could. And there's this group of, again, very smart people who are working on this project. And I participate in their meetings frequently. And I always say my job is to kind of be the translator between their really high level, super intelligent knowledge on technology, and then what people like me see as that cost effectiveness, the really applied elements of it, because you're not going to make decisions that are going to hurt your bottom line if you're a business. And so translating that there's pure research, which is really important. And then this center is actually going to be focused on the applied research. So how do you make it so that it's a tool that serves business in that real, in that perspective of global competitiveness?
The next speaker is going to be Jose Casillas. Jose is well known on the island of Puerto Rico, having built successful businesses. Jose is going to give us a perspective of someone on the front line of energy systems. And Jose, you know, first, thank you for volunteering your time and sharing your expertise. But if you could say a little bit about yourself, because you've got a remarkable background, and then, you know, give us your perspective on energy development.
Sure. Thank you, Jeanette, and thank you for the opportunity. Obviously, we appreciate the time of people are taking to be here with us in this webinar. And we're really excited with the potential opportunities that we see happening in the future in Puerto Rico, as Gail mentioned. I'm the managing director at Hub Advanced Networks. Hub Advanced Networks is a wholesale telecommunication and infrastructure and technology services provider based in Puerto Rico. We have been in business for the last 17 years. And we basically manage fiber optic infrastructure for the carriers in the island, in the Caribbean. Also, we provide connectivity to the East Coast of the United States, to South America, to Central America, and to different islands in the Caribbean. Also, we have one of the most advanced buildings in Puerto Rico. It's called the Hub 787. It's a cable landing station and also a data center. We provide high technology services from there. We provide virtual computing. We provide IP exchange, co-location, and many other advanced technology services. And we have been in the market for, like I said, 17 years, working with the power utility, the water utility, and the carriers. And we are very excited with the potential that the grid modernization plan brings with. I will talk about that shortly. If you want to know more about Hub Advanced Networks, feel free to go to our website. It's www.hub.pr. Browse the site and feel free to contact us, or click the Contact Us tab on the top of the page and send us a message. We'll get back to you. The Hub Advanced Network is also a member or a partner of the Puerto Rico 5G Zone. We're working along with InvestPR, Sellers Capital, the Indiana 5G Zone, and other great partners to make this happen in Puerto Rico, to have Puerto Rico become a 5G technology development site in the Caribbean. So whenever you need more info, just go to our www.hub.pr. By now, most of you should know that PREPA published its 10-year infrastructure plan last December. And the goal for that plan is to create a new grid for smart energy operations in Puerto Rico. It is a well-structured and very ambitious plan, like Gail mentioned, to modernize the grid. They plan to rebuild the grid during the next decade. And in the process, they'll reimagine the new energy grid at all levels: the generation, the transmission and distribution, the customer service, and the information and operational technologies. And if you notice, I have the information and operational technologies on bold in the presentation, because most of the opportunities that will be on the 5G technology field are related to that level. The 10-year plan objective is to build a smart, resilient, and reliable and sustainable energy grid. And that's very crucial for Puerto Rico, for the reconstruction of Puerto Rico, because more than delivering energy, the energy grid powers all aspects of Puerto Rico development, not only economic and manufacturing and industrial development, but also social and community development as well. This energy grid innovation will create new technology development opportunities across all fields. So we are at the PR5G Zone are really excited with the potential opportunities that this initiative will bring into the future. For those of you interested in getting a copy of the PREPA's 10-year infrastructure plan, the link is on the bottom of the slide, but it's a kind of long link. So you can Google it and you get that link and you can download the document for further reading. Most of the innovation and 5G opportunities are related to the information and operational technologies of the smart grid. The objective of this level at the plan is to enable and support the automation and modernization of the electric system operations, the telecommunications, the connectivity, and security of utility assets, including their SCADA system. So they will basically revamp the old SCADA system with a new generation data and acquisition system. They also install a new advanced and distribution management system, which is the system that you use to manage your distribution and your power outages and the field work related to distribution crews. They will also enhance the cybersecurity to protect the grid from attacks. They will add something that is new, and that brings really a lot of good development opportunities in the 5G area, field area networks to the grid. And that's something that will change the game in terms of the power grid reliability. They will basically distribute areas with providing smart functionality for the system to be self-healing and resilient. Also, they will update the control centers. They have, PREPA has 2 control centers, one in the north and one in the south, and it's part of that plan to innovate those centers as well. The smart grid comes from this level of the plan, the IT/OT capabilities. This layer has to be able to sense and communicate changes in the grid in real time. And once they do that, they have to analyze and act on those loads and grid conditions in real time. So yes, you'll need a very robust network, and you also will need a lot of computing capacity to analyze and act on the events that happens on the grid in real time. This infrastructure, as planned by PREPA, will provide ultra low latency. We're talking about sub-milliseconds across the network to support this real-time response. And I can't stress this enough, they will add advanced cybersecurity protection to protect the grid from a hacker's attack. To support all this functionality, this real-time response, this real-time analysis, they will add a new wireless network. The plan doesn't really specify a 5G wireless network, but when you go and read through the plan and understand the functionality they want to add, you know that the technology available now is going to be either late LTE or 5G. And in my opinion, it's going to be 5G by the time they start working on this. The plan has these scopes to be completed during the first 3 years of the plan. So PREPA is actually working on this as we speak, and their wireless network must be able to enable low latency and process high bandwidth communications between the systems and the grid devices. Also, it must support ultra low latency and high density with the new distribution devices. The customers, the functionality you want to provide, the smart functionality you want to provide to the customers to manage their loads and energy use, the IoT devices that will come with the modernization of the distribution substations. And all these devices could grow into the thousands, even into the millions as we go into the future. So they need a wireless platform that is scalable enough to support all these devices. Again, it's a wireless network that needs to be optimized for the energy grid operations to support sensors, IoT, actuators, and new T&D devices. To support all this wireless network, PREPA is proposing in their plan a robust and resilient fiber optic backbone with backup microwave radios that support high volume data transmission and high capacity computing. This is great news for the wireless industry in terms of that the grid being modernized lays a foundation for the development of new technologies. And there are new opportunities that can now be realized if PREPA completes this modernization phase in the next 3 years. Next slide. And those opportunities that we can start talking about now is smart manufacturing, IoT applications, mobile applications development. With the grid being smart and reliable, now you can share information with the grid into your applications in terms of the smart manufacturing scenario, and make decisions in your process to protect or maintain production of certain lines. Also, we can start talking about advanced computing facilities. Now with the reliable grid, you can now consider other areas in Puerto Rico, the west or the south, to create advanced computing facilities. Also, we can provide industrial ultra-low latency network to different industries. Really now tap into the smart cities projects that we have been planning for a while. Deploy augmented reality system, virtual reality systems, remote machine operations, healthcare, robotic and industrial automation, edge computing. In fact, many other possible developments using 5G technology that will be possible building, will be possible to build them on top of the stable grid and smart grid. The Puerto Rico 5G zone primary goal is to help the government, industry, and the academia better understand the challenges to develop these opportunities presented by 5G. This is great opportunities ahead, but they are not without challenges. We are working at the Puerto Rico 5G zone with all our partners to face the high cost or work with the manufacturers to reduce the cost of 5G equipment. You will hear about some of the panelists in terms of the equipment available and options that can be used to accomplish this. Also, the security. I can stress this enough, like I mentioned before. It's very important for the security aspect of the grid to be really solid and ready to keep the grid from, or protect the grid from cyber attacks. Also, there are panelists down in the next panel that will go into those details. The network deployments to make sure that we have the resources, fiber optic towers, and that's something that the Hub Advanced Network is working with, along with the PR5G Zone, to make sure that this happens here in Puerto Rico, and we can create a 5G lab in the short term. Also, the spectrum, are we going to use CBRS, shared spectrum, dedicated spectrum for these developments? That's something that, again, the PR5G Zone is working with the National Spectrum Consortium, and the regulation and permits at the federal and the local level. We have to comply with the requirements to be successful. Again, the PRG Zone and its partners are working to tackle all these challenges to speed up the process and the development of 5G technologies in Puerto Rico. In summary, the Puerto Rico Energy Grid Reconstruction lays the Energy and Telecommunications Foundation for developing an advanced manufacturing environment in Puerto Rico. That's what Gail was mentioning. I think we have the right elements to be successful at this. And with that grid innovation and the development of new 5G technologies, will push Puerto Rico industrial environment into the Industry 4.0 revolution. And that will open the door for many other opportunities using big data, cloud computing, automated robotics, etc. The PR5G Zone is working with its partner to deliver technology breakthroughs by creating the first PR5G Zone lab in Puerto Rico with samples and testbed. And if everything goes well, in the next couple of months, we will have that lab working, delivering business innovation through technology transfer and cooperation with the academia and the government and the industry. Also providing resources to help assess the economic viability for various 5G use cases, and creating the one-stop shop for complex 5G research in Puerto Rico. Again, you can also join us at the PR5G Zone. You can visit our site, is PR5GZone.org, and be part of this initiative. So you can visit us there and register, and we will get back to you. And next, that's my presentation today, Junaid. If you have any questions.
So one of the things, so I've actually had the chance, an opportunity to work with Jose. And one of the things I've learned from Jose is, typically when you work with system integrators, they expect other people to do everything. Jose, I've learned, is very hands-on. He not only really wants to understand the technology, not as a customer, but as a developer. But the other thing I really learned from Jose is he is not afraid to rapidly prototype something that has never been done before. And, the reason I say this is when you talk about energy, one of the big issues is just mismanagement, where people just waste a lot of money. And one of the things I've learned working with Jose is rapid prototyping, not being afraid to get at the developer level. Jose, it would be great if you could share with the audience your particular unique approach, which is you know, you don't actually take anything as fact, and I've seen you work. Anything somebody says, you actually, so let's do it. I mean, I've seen you do that over and over again. You want to share with your with the team your I guess your strategy, and it's really how you work on the importance of rapid prototyping, everything, getting that hands-on feel before you make the big decisions.
Sure. Our strategy here, it's you know, fail fast. Let's get hands on it. And if it doesn't work, let's move with the next thing up. And that works in the development area, because if you wait too much time, you are wasting resources, maybe on things that eventually will not work. So we try to tackle everything fast and make it happen. If we find problems in the way, we'll try to fix them. If it not, we'll change the approach and move forward. That's our motto, basically, on how we do things.
Our next speaker is Andrew Dicker. We're very excited to have him. He's got a lot of frontline experience on large-scale energy issues. Andrew, if you could introduce yourself and share with our audience some of the insight that you've learned working on these projects at kind of the front line.
Absolutely. So a little about myself. I'm Andrew Dicker. I'm a managing director with Accenture. It's a global systems implementation and strategy firm. We have about 500,000 employees worldwide, working in every industry. I'm focused on utilities. Have been working with utilities for about 15 years. Have worked with about 20 different large utilities on the mainland and the Caribbean over the past 15 years, all of which having more than 500,000 customers, so very large utilities. And you know, I think it's great to have this collection of folks on the call. You know, a lot of very innovative work that's being done across my fellow panelists. So you know, it's great to hear some of their perspectives. You know, I think just as a starting point, you know, for some thoughts, we've heard questions about, you know, clean energy. We've heard some questions about the value proposition, and you know, are we wasting money, or you know, is it worthwhile? And I just want to start out from some of what we've seen. A lot of what I do is tied to business case development. That is tied to you know, investment programs for infrastructure, for utilities, looking at programs that are tens, hundreds, or billions of dollars. And in many cases, as regulated monopolies, utilities face an incredible level of scrutiny from their regulators to make sure that it's prudent investments. And you know, there has been a mega trend over the past 10 years, initially spearheaded by the Department of Energy around 2010, that has been was originally subsidized, but has demonstrated sufficient value over the past years that many utilities are pursuing it independent of subsidy, not just for you know, reliability improvement, which is their core charter of making sure that the lights stay on, but increasingly investments that are helping for energy efficiency and trying to help reduce customers' energy bills. So, you know, with that, if we could go to the next slide, you know, I think one thing I'd like to challenge everybody to think of, which utilities have a very unique position on and a challenge, is they have an operating control center. I think Jose previously was saying that there are two in Puerto Rico. But one of the major challenges that utilities have contended with for decades is, how does the control room operator, who is trying to monitor and control all of the assets in the field, how do they know what's actually in the field? When you have hundreds or thousands of line miles, there are many potential points of failure to know about that. And historically, it's been dependent on having people in the field that can see eyes on the equipment and report back to the control center. So, I think the 5G concept is really interesting to consider. How does that really change that paradigm to enable the utility to be able to better monitor and control the grid? So next slide, please. So I'd like to just to introduce, and I've seen a preview of some of the presentations from some of my my colleagues on the panel, so they'll probably be talking about these as well. But at a high level, there's three broad technologies that have been coming about, maturing, and being deployed across the utility space across the past 10, 15 years. Very broadly, it's about advanced meters, distribution automation, and distributed energy resources. To start with advanced meters, historically, meters were really just like a gas pump, a means of measuring how much a customer consumed in order to generate a bill. But there's been a tremendous amount of adoption. 55% of customers on the mainland now have a smart meter or an advanced meter, which allows the measurement of energy and to produce bills, but also act as an IoT device, an Internet of Things device that has a large collection of sensors to be able to provide insight both for customers to help enable them to save money on their consumption, but also to provide much more insight for the grid operator. Now, the meter is at the endpoint. There's also a question of the grid. There's been a big adoption of technology in the realm of distribution automation. There's a wide variety of different technologies that you'll see connected to grids across the country. One particular type, which is an energy-saving device, it's a capacitor bank or a voltage regulator, can be coordinated through a technology called volt-var optimization. That has been adopted by 23% of utilities across North America, and really just deploying that over the past 10, 15 years or so. And that in particular is focused on saving customers energy. So when we talk about trying to invest in these things, it's not just throwing good money after bad. There are very solid business cases that underpin and justify these investments. The most emergent technology is distributed energy resources, which is a blanket term that the industry uses for things like rooftop solar, energy storage, electric vehicles, demand response capabilities, and microgrids. This is decidedly the most emergent. And the last I saw from an EIA report was for some of these small scale solar on roofs, for example, it's only at about 3%. Now, the utility scale, which is connected to transmission lines, is perhaps a bit more, but these are very much what a lot of the industry is talking about, thinking about, and is especially important for Puerto Rico to consider flexibility and resiliency to be able to leverage these in different ways to try and mitigate challenges. Now, I was asked to go into a little more depth about what some of these are. So if we could go into the next slide. First, I'd like to talk about AMI, Advanced Metering Infrastructure. This technology for metering can be used for all sorts of commodities, such as natural gas, electricity, water. They provide a number of different types of communication technologies. They have embedded ability to talk to one another through what's called a mesh. They can talk over power lines. They can be connected through fiber optics. But many utilities will use public cellular infrastructure as what we call the backhaul in order to get that information back to the utility. That would be very important to enable some of these sensing devices and insights from the device to come back. Additionally, it can have the ability to, when customers are moving in and out, it enables the utility to remotely connect and disconnect, turn on and off the power to benefit the customers when they're not there, can upgrade the firmware, can be remotely pinged to try and help customers to understand whether a power outage is something that is on behalf of the grid or whether it's something that's faulty wiring within their home. But the sensors and the amount of information that can be gathered at the endpoints is really important, because it can start to identify outages. It can determine voltage surges and sags. It can identify various information about how energy is being used to help the grid operator know what's going on so that they can better respond to various challenges. Another technology on the next slide, if we could, is in the realm of distribution automation. And I've tried to oversimplify an electrical engineering drawing here, but on the left-hand side, there would be a substation and then 2 circuits by which energy is delivered to customers. I have a number of circles on the left, which shows that maybe there's 1,500 customers on that circuit on the left. And in that situation, no customers are out. But imagine if you step forward in a traditional infrastructure without distribution automation. I have a little lightning bolt there on the left-hand column. When that lightning bolt happens, when a fault occurs and a power outage occurs, historically, it could be the entire circuit that's out, 1,500 customers that could be experiencing a power outage. But there are certain capabilities like reclosers or switches that have increased intelligence to respond to grid situations. Sometimes it'll be referred to as the self-healing grid. So in the third column, you might see an instance where R1 is a switch that will automatically open to enable the 500 customers who are closest to the substation to maintain their power, even while a similar fault condition is occurring. Now, in that case, maybe it's only 1,000 customers are out. But the best possible situation is to have enough of these devices on the grid where they can be remotely monitored and coordinated by the control room operator so that they can reconfigure the grid by allowing the right-hand side, where power is going through R3 and R4, to come along and be able to restore energy at the end of the circuit. So for those 500 customers that are at the bottom left between R2 and R5, those customers can only be restored if there is sufficient telecommunications allowing the grid operator to be able to monitor and control those devices on the grid. So there has been a lot of traction across the industry of looking at these technologies and communications as a means to enable resiliency and reliability. You have devices in the field. Those could be distributed energy resources, distribution automation, or meters. They need to communicate through a field area network and a wide area network. Again, those could be 5G, could be fiber, could be a common network that is used by all of these devices in the field. And in fact, for Puerto Rico, something like that may actually make a lot of sense to try to make sure that the investment in that infrastructure is being maximized and being used as effectively as possible. And eventually, once the data makes its way back to the back office, it's collected and it's organized through an array of systems to analyze that data and drive insights. Now, the important thing to consider about that is the communication from the field to the back office. That's how it's always been. At that top line, it's based on people, but the latency of that has been minutes to days, weeks, or even months. And then as we look to the emerging technologies about meters, distribution automation, and DER, we see that there's an increased need to have that latency be faster and faster to handle more and more data, something that 5G could be well positioned to support. Last slide, if we could, is a question really of the interdependency between the smart grid, electricity, and telecommunications. As you look at the image on the left, it's an example of antennas. right? And those antennas, they could be hardwired in for telecommunications, but they also need power. They need energy. And that, that needs to be able to have that electricity in order to operate. But at the same time, it's very much an intertwined ecosystem, because the electricity grid increasingly needs to also have insight and the ability to have the telecommunications to know what's actually happening in the field. Which raises the question of what happens when there's an outage. What happens when there's a failure on either side? For the telecommunications for 5G, there's a certain level of planning for contingency. Some of the 5G network can be designed with battery backups or can be interconnected to microgrids to sustain communications. The challenge is on the utility side, when the telecommunications goes down, there's relatively little that can be done in terms of having backup plans. So what right now the state of the affairs in the industry is really to look at a lot of autonomous configurations to make sure that some of these investments are able to operate as best as possible independently without communications. But clearly, there's significantly more value to customers and society at large if the utility can be able to leverage high-speed communications. So I thank you very much. I look forward to hearing the comments from the rest of the panel, and would love any questions along the way.
Great, Andrew. Thanks for that. So we did have 2 questions that came in that are kind of relevant to you. One was on what's the approximate phasing, say over the decade? How do you, because you work on these large projects, is there some simple ways that people should think about what's realistic in 2 years, 3 years, over a decade? The second question, which is from the same gentleman, Mr. Riley, is kind of related, is the business case of an individual smart meter. Is that something that is continuously subsidized, or is that something that at some point generates efficiency, so it actually starts paying back the utility who made the investment? So they're kind of interrelated. What is the...
So for the smart meter, let me take that one first, if I could. The challenge is it's sort of one should not think of a meter only as the investment. A meter, a smart meter, a digital meter unto itself doesn't really provide incrementally that much more. The value proposition of the smart meter is when you're connecting it through the telecommunications and integrating it to the back office systems. So when you think about an overall AMI program, you can't really just think of an individual meter. You have to think of the meter and the installation and the telecommunications and the cybersecurity and the back office and the analytics. So when you take all of that together, right, it's more than an individual meter, right? It's a system in aggregate. Many of the business cases that I've worked on will look at a 15-year business case. And pretty much every regulatory engagement that I've seen, the regulator will not approve it unless it's a positive business case. The business case can be highly beneficial to individual customers, but it's also dependent on how the customers want to avail themselves of the opportunities that are present. There are different technologies like time of use rates, time variable rates, other forms of insight, high bill alerts, et cetera. If customers don't want to avail themselves of some of those, then they may individually find less value. The other side of it is, for some of these deployments, they are multi-year journeys. An AMI program, many of the AMI programs that I've seen are at least 2 to 3 years. For some of the devices in the field to be connected, they are multiple phases. I've seen some utilities in the Northeast that have limited windows to install because of ice and snow. They look at like perhaps 15 or 20 year long deployments. But on the flip side, I've also seen some utilities in, say, Texas that have been able to deploy reclosers in the span of, say, 2 to 3 years. So it's all a matter of having the regulatory approval, the funding, and the people available to be able to implement those changes. But the industry is very much seeing that there's value to these. Otherwise, the regulators wouldn't be approving these investments.
Our next two speakers come to us from the wonderful state of Indiana. We're going to start with Mr. Sean Hendricks, who is becoming a national celebrity in his own right. For those of you who know Sean, he's doing some of the most cutting edge work in networking, 5G, unlicensed and licensed, with smart manufacturing, digital agriculture. So with that, we're very, very lucky to have Sean, who will give us a kind of frontline perspective on some of the innovation that's happening. Sean, Sean, I think your mic is muted. I don't know if you want to.
Yep, are we good to go?
Yeah, you're online. You're live to the world.
All right. Hey, thanks, Junaid. Too kind as always. I guess one of the things I wanted to kind of start off this section on smart energy about is what makes energy smart, and why do we care about energy from a 5G perspective? So I guess, so I want to start and really, in some ways, frame and build off some of the prior speakers' thoughts on the concept of smart energy. So as I start to think about it, smart energy is really about decoupling the load from the generation. We've seen some examples of what that means with multiple generation sources, but now add in this idea of decoupling those sources from the loads, and we enter into a discussion about energy storage. And so we're all familiar with batteries, but there's a number of energy storage technologies. And so part of being smart is thinking about how to then integrate these decoupled sources, when to store, when to generate, et cetera. So this all then starts to bring into the concept of new power architectures. These power architectures can be developed to develop resiliency, but also to bring in sources from multiple generations, multiple load types, potentially even multiple forms of storage. So we have to think about it not just from the individual elements, but also how they are architected together and interconnected. And so, we quickly find ourselves into an increasingly complex environment. So now we're talking about energy management, which has a control system component. And so now we're starting to get into some of the complexities that we want to bring into our energy systems, because we want to take advantage of green, renewable, locally available technologies. But now we have to get, quote, smart, because it requires much more advanced management and control of these assets. And then we introduce the concept of distribution or distributed nature of these. Storage may be located near or far from the generation sources. Loads and other multiple forms of generation may be distributed. They may be clustered together in microgrids or nanogrids, or spread out as more grid level resources. And so in addition to the control component that I mentioned earlier, we now need to think about monitoring connectivity of these diverse sources, loads, and storage. And then how are we going to manage this entire network now as a set of resources that now needs to be optimized for reliability, for cost, and other factors that either customers or network operators, power network operators, care about. And so to me, that kind of builds up the rationale for what makes energy smart and why 5G plays a role in energy. Because at the end of the day, whether we're talking about smart cities, agriculture, manufacturing, we're talking about large complex systems these systems, in order to manage, operate, and optimize these systems, you require massive amounts of data. That data needs to be, it becomes critical because we're talking about infrastructure, because we're talking about mission critical infrastructure. There needs to be strategies for failover or reduced operation based on conditions or loss of some assets. And so we get into these, again, we get into the concept of smart energy from that standpoint. So how do we do this? How do we, so we've built up a rationale for smart energy, but there's also some big challenges with that. So when we start talking about architectures, some of the speakers coming up here in a minute are going to start mentioning about power and controls. And so that becomes important to us, because if we're talking about it from a 5G networking standpoint, our term might be more along the lines of IoT, so IoT connectivity. But in order to have, we've got a diverse set of generation sources, storage types, et cetera, and we're going to have a whole massive amount of devices that we need to connect in to control this. So the thinking of an open architecture starts to become very important to us to address the challenge of these complex architectures, but one that, if they're not open, if they remain closed, then becomes very difficult to implement and to manage over the long term. And then I mentioned, you know, the 5G element of, in terms of the communications and the data processing. And I think it's worth mentioning or thinking about here, now that we have large physical assets that are interconnected, both from a power perspective and from a network perspective, and we need to be thinking about cyber physical protection. So in addition to all of the challenges of just managing all of these devices, now we have to be thinking about a security layer and how we implement that. So the concept of adding in cybersecurity at the embedded level, operating as if we are in a zero trust environment. So our networks, even though we like to think that our cellular networks and our other communication networks are secure, the reality is that there's a number of vulnerabilities, both known, and there will be new vulnerabilities exposed in the future. So as we think about critical infrastructure, we really need to assume zero trust inside of this, inside of our communications networks that's controlling this critical physical infrastructure. And as we're thinking about this cybersecurity problem, we also need to be thinking about not only the data that's being transmitted or the communications lines, but we need to be thinking about the data that's also at rest, the algorithms that are controlling. So the data at rest, as well as the data in motion, the data in transit. And so with all of these challenges that we kind of outlined here, there's huge opportunity. It's also worth mentioning here that while we talk about communications, we talk about 5G, we talk about IoT as if it's one thing. And I think that, you know, as Jose mentioned, as Andrew was getting into, that we need to really look at this from the perspective, the challenges from this perspective, that 5G communications is not one thing. Our smart energy is not one thing. And so we have a diverse group of technologies that have to be brought together. Interoperability becomes a big challenge for the industry, but also selection of the right type or piece of these 5G technologies. I'll address more on the 5G side. We could also have the same discussion on the generation, storage, and load side of the equation as well. But why is 5G not one thing? So if we look at this from, maybe some of our audience is coming at this from the this presentation from the, call it the energy perspective. Maybe they're folks that are experts in generation or operations management of grids and other energy resources. And a lot of people would perceive 5G technology as either it's the same as 4G, or, you know, my internet works, I've got internet today, isn't 5G just the next G? And don't I just plug it in and it works like my USB mouse does on my laptop computer? Well, the short version is no, it doesn't, right? Because 5G is about spectrum, 5G is about massive connectivity, 5G is about low latency communications, 5G is about edge processing. This means that we have much more complexity in terms of selecting the spectrum that we operate in, be it licensed by traditional carriers or unlicensed spectrum. We have a lot of difficulty or challenges associated with how we route our data, whether that data is going up to cloud, or now as you get into 5G networks, you're talking about the advantages of edge compute. So taking on these challenges is really a big part of 5G. So really what the whole purpose of that background is really to say that integration and interoperability of these technologies to get to a solution that is not only functional, but one that can withstand, can be validated in its cyber environment is very important. And this is where the Indiana 5G zone as a test bed operating in licensed spectrum over 5G with millimeter wave networks and edge compute really becomes a location, a place, a test bed where this interoperability and system of systems work can be achieved. We've had the opportunity in the last 6 months to really start to pick away at some of these practical challenges of 5G by implementing, working with partner companies on things like encryption as a service, working on some of the complexities of data routing with IoT. These all become fundamental work that gets us to the higher level or the application use cases that enable things like smart energy, like digital agriculture and manufacturing. However, it is not enough that we just are a lab in Indiana working on these problems. These problems are much larger than any one entity. And so building collaborations, partnerships, groups of laboratories that interoperate with one another, groups of companies and technology stakeholders that all work together is an important principle as we look forward to developing these applications. And so in addition to the Labs Across America initiative that we're part of and very thankful to be part of with the National Spectrum Consortium, it's also critically important that we work with partner laboratories such as the Puerto Rico 5G Zone to share the learnings that we've achieved, help with sharing companies and technologies that we've worked with, and the successes and frankly some of the difficulties that we've had in developing these technologies. So I just wanted to take a few moments and give a quick kudos to Jose and the Puerto Rico team. It's been fantastic getting to know them and share our lessons learned, and we're looking forward to working with them on more projects in the future. And I think as we look forward to the future and we look at energy applications, we can start to build test environments where we can leverage not only the networks and the capabilities in Indiana, but we'll be able to add in or network over to the capabilities that will be added in the Puerto Rico labs. So from that perspective, we'll be able to pilot, prototype, and run experiments on much larger scale networks in the future to then validate some of these challenges of interoperability and security that we described earlier.
Hey, Sean, thanks for that. Just a quick question, though, and a comment. I've had the opportunity to interact with you, and one of the things I've learned as you work in the 5G zone is the interrelationship between smart energy, smart manufacturing, transportation, digital agriculture as products go from factory to factory. So the thing I really learned watching you is the understanding that relationship, working with the ecosystem partners, because it is almost like smart infrastructure. Can you make a comment about the interrelationship? And I know you spend a lot of time on connecting people who are farming to people who are building batteries for autonomous vehicles, and people today really see them as separate industries. But I think what you've really identified is the interrelationship between all these things. So it's almost like a smart ecosystem or smart infrastructure, and the importance of getting that all right.
Yeah, it's so I think what's we look at these applications as being so different on the surface. Like, what does a farm have to do? Like with the mobile power charging station, like we're looking at here in the picture. And the answer is, well, on the surface, they look completely different. But if you start to look at it from a connectivity needs, you look at it from the devices that are enabling that connectivity, called the IoT, they exhibit a lot of similar characteristics. Characteristics from the data, the need to secure that data, and frankly, the need for low cost, very efficient, and easy to implement solutions. And that's because whether you're a agricultural application, manufacturing, or something like a motive application like you see below, these folks are experts in their field, and they need something that's easy to implement and doesn't change the fundamental value proposition that they have for their solution. In other words, communication should enable what they're doing. It's not really the focal point, right? The point of ag is growing food. The point of electric vehicles is to get people and products from point A to point B. But again, the underlying technologies, we can share a lot of information, whether it's on the device side, the security side, how do we do the routing for the applications. These are things that can help all the applications move more quickly to get them to their end state, their minimum viable product, or get to market.
Great. Thanks a lot for that insight. And I think this interrelationship between industries or different industries is going to become a bigger and bigger, more important theme as we start deploying these systems. Doctor, if you could introduce yourself and tell everybody about some of the cool work you're doing that I think most people won't even believe is real.
Great. Thank you, Junaid. Thank you, Sean. I'm Nima. I'm chairman of the Advanced Renewable Power. And also I'm faculty member of mechanical and energy engineering at Purdue University as well. So what he's talking about, this is our physical model, which we are testing as we speak, is a mobile power grid. So what is mobile power grid? A power station is just the electric utility company, or sometimes I refer say IPL, Indianapolis Power and Light, for a community, okay? For a community. And what is a community? This is a cell tower. To us, this is a community that in the middle of nowhere. Actually, there are active projects, like this is in Ethiopia. And then what is another one? The cold storage system or cold chain to help farmers to protect their crops. So we have it there. So the mobile power grid has the power generation, power energy storage, power management to manage all these devices. We call them, you'll see 5G InfiniGrid, and also power conversion, universal power conversion system, so we can accept any kind of power in or out. So these are another example, a power, basically here we have a charging station, a mobile charging station. Here we have multiples of platforms, and you may want to look at all these platforms as IoT devices, the fancy word these days, IoT devices, that we have to somehow manage and repair and diagnose globally through the 5G network. Also, we have a specialized wind turbine, as Junaid says, a shrink. This is as large as a refrigerator that sits on top of a building or any tower. And we have very advanced, what we call them, high-speed turbolizer inside that basically gets a 5 meter per second wind and convert it to a 75 meter per second wind in order to generate high energy, 10 kilowatt, basically, some system that we have here. Our team are the guys, we have a bunch of other, executives from the industry, communication industry, energy industry, power industry, battery industry. So including myself, and we have multiples and multiples of different technologies that we have developed for other countries as well as other companies that are in production. Why did we do the mobile power grid? 50 years ago, 40 years ago, some of them I remember, half of the world population didn't have telephone. Why? They had to wait till the landline comes to their house. We had money, but I didn't have telephone because I had to wait for it. And mobile phone enabled people to have phone communication system. Why? They don't need landline. We're doing exactly the same thing for that. Mobile power grid is exactly analogous to a mobile phone. So 1.6 billion people, these are not our numbers, this is McKinsey's number, they don't have electricity right now, right? Why? Because they have been waiting for the transmission line to come to their house for the last 50 years. Well, you say, we have good news for you. You don't need it anymore. It's done, right? We don't need transmission line. Well, some people may disagree, but you just have to look at the future. That's the way we're looking at it. 80% of the people here, they have zero access to electricity. You're in the middle of nowhere. And even if there is a transmission line available, it's not economically feasible to do that, right? So that's why we built the mobile power grid, and we have been doing research on the mobile power grid. We currently are working, of course, in the countries in Southern Hemisphere, which temperatures are high and roads are very harsh. I mean, Puerto Rico could be classified as that. Temperature is high, and those all the devices we're talking about are very temperature dependent. So we have lots of technologies in those areas. We're currently working actually in Senegal. I'm going to mention the country. They lose half of their agricultural products because they don't have mobile refrigeration system. We call them the cold chain system. A mobile power grid sits next to the cold chain system, will generate that refrigeration to protect their crops. 50% are being lost. And again, another example in Africa, they have food, that their food is being wasted. The second phase that we're working also the same thing with the School of Agriculture to actually help them to increase the crop. All these things, all these technologies, they need communication. All these things need communication. So we go, basically they have no clean water, no healthcare often, no education. And this is another area of technology that we have developed. I have got several grants in this area. We call them the immersive global universities. That's another subject we'll talk about in the future. Or the digital economy, the biggest again, digital economy. Some of these countries and some of these people don't have any idea what is digital economy, right? So we are enabling them, but in order to do that, in addition to electricity, of course, electricity is the main thing, right? Anything that you want to do these days, you have to have electricity. And then everything else comes with it, which is next step is communication system, which is the 5G communication system. Now, what do we do? We call them the InfiniGrid or 5G InfiniGrid, the core of technology, which is energy management system. All those devices, hopefully someday we have millions of them out there. They have to be somehow managed through the system, the 5G system. We used to call it data mining. Now we have data mining, artificial intelligence. This enables us to do all we wanted to do and managing all the energy and all these devices across the globe. Now, the biggest thing, we at least look at it, no transmission line, right? We have talked about the Puerto Rico. Yes, you can build the grid, but also remember that hurricanes is going to come again, and it's going to come very many other times as well. So we have to come up, do something that if they come, we don't have to go through the same process again. These devices could be mobile and could be moved to some secure area the day before, and they come back the day after the hurricane is gone. Now, what do? We work where there's no power. Obviously, there are very many places there is no power, right? Our design is for countries which they have no power, and there's a desperate need for it. We run cleaner and greener. Obviously, it is. Some of the examples that we have, we could save even by the storage alone, we can save 50 to 70%. Ideally, we want to put 100% no fuel consumption, no fossil fuel, by using the solar, wind, and other technologies that we are also developing and partnering with other companies. We work faster. Why do we work faster? Because If you go to the energy systems, energy storage system, temperature is the main thing, almost controls everything. We have a specialized thermal management system, very high speed, for the people who understand batteries and stuff like that. All the heat sinks, conduction, cooling, all the stuff, we just eliminate the whole thing. We have totally new technologies in those areas. For time, I don't go to details of that, but we have technologies that we can discuss with anybody who's interested. We work longer. No, the batteries today, environmentally, people who are interested in environment, regular batteries could die, not lithium-ion batteries could die in 3 years if you're lucky. And we have experience with these technologies that out there. We can guarantee 10 to 20 years. Some of the stuff that we have, they are going there 10 to 20 years. We have quite a few patents in these areas. We've got lots of government grants, which we'll talk about them shortly. And we're also, for the technologies that I just spoke with you, we have filed several provisional patents as well. The key is here, how are we going to do that? The word to us really accessibility. Currently, example of, again, south of the world or the southern hemisphere, in Africa, accessibility is right now 23%. Well, with our technology, we believe we can go to 100%, particularly having the 5G network, high-speed network, that we can enable people to do that, right? And manage all the technologies globally. And on the business model, of course, we have been working on 5 major joint ventures that we are working on in India, in Ethiopia, in Senegal, Brazil, United States. Hopefully this will become our United States. Me being from Purdue University, we have also donated, for the one who are 1 million shares of our company to Purdue University, just for your information. The point is, we also have, as you know very well, we have the top 10, at least people say top 10, I say the top #1 school of engineering in the world in this area that can support, that is supporting us actually, that we were working with. Now, some of the agreements that we have signed with, this is gentleman you see here, the Minister of Energy in Ethiopia. And on the right-hand side at the bottom, you'll see they're one of the largest companies in India. And we have signed also the agreement with the government of Senegal. And hopefully we'll do the same thing in Puerto Rico soon. And we're working on several others, maybe the USA become Puerto Rico in this case. Now on the scientific areas, if any, we have got funding from Purdue Foundry, Elevate Ventures, our engineering and company, basically, we do engineering services company, DOD, SPIRs, we're from the Defense Agency in the armor technology, and DOD also from Army, DARPA, Navy, Indiana Economic Development Corporation, Indiana 5G Lab, that we're working with the lab right now to integrate our system to the 5G system, and expecting several other grants coming hopefully soon. We're invited by National Science Foundation to write full proposal, which we did. Also, we are invited by Department of Energy to write a full proposal for the systems that I just described to you. That's our contact. We'll be more than happy to work with you, chat with you.
Great. Thank you, Dr. Nima. The idea that you're able to shrink all of the components in energy generation and distribution to things that fit on pickup trucks is kind of new, because when you think of the word energy, what do we think of? We think of gigantic buildings. We think of things that are permanently stuck to the ground. And Dr. Nima is really working at the cutting edge of what is possible in terms of shrinking it, making it portable, and making it intelligent. So again, thanks, Doctor, for your presentation. We look to continue to collaborate with you, not only in Indiana, but in Puerto Rico as well. Thank you for that.
Thank you.
I'd like to introduce Brian Wayne, who's been working both in Puerto Rico and Indiana on new secure communications systems to link basically sensors to not only generation, but also to users all at the same time. So Brian, you've got the virtual screen, as it were, on the mic.
Thanks, you did. Hi, I'm Brian Wayne. It's nice to be here. Thanks for everyone's time and attention. So XQ is a smart data protection platform that provides encryption as a service. We have been lucky enough to work with Nima on his advanced renewable power mobile power grid, and with Sean Hendricks from the Indiana 5G Zone on that as well. But just to get started a little bit about XQ, we are a service that securely tracks your data wherever it goes on one united platform. So you can use our APIs and SDKs to integrate into any application that's out there and speak securely across different platforms. Next slide, please. So it's a new distributed architecture. Better to just go into the benefits of it. We're quantum safe. We stream quantum random numbers to the edge. We are crypto agile, so we're able to use the most recent cryptographic algorithms available. Every event within the network, or actually outside of the network, everything that happens to your data is logged with geolocation and identity, and we're built for scale, so we can move to billions and trillions of transactions a day. Next slide, please. So this takes us a little bit more deeply into the mobile microgrid that Nima was just describing. And specifically, I'm going to talk about the encryption and security. So we're talking about smart energy and encryption here, and smart energy and security. So we look at the mobile power grid. As Nima mentioned, it can connect to any different type of energy source. So that can be solar, that can be wind, that can be diesel. Now, when we think about like, what's the purpose of a mobile power grid or a nano grid, this may be obvious, but it functions without being connected to the main power grid. It can connect and it can serve power back into it. But essentially, when we think about what this thing does, is it brings in the energy resources and it stores that stuff in a battery, right? And then it distributes the energy intelligently, right? So we can call this like an islanded electrical grid. Attached to this is the cyber server. The cyber server is just a very smart IoT gateway, which is essentially like a Linux with a 5G antenna on it. So all the information that's coming out of the energy management system goes into the cyber server, and then it's managed by the XQ application, where it's encrypted. We talk to the XQ cloud platform, generate our keys at the edge, encrypt things, send the information back to the cloud platform, and then through the cyber server, connect to the 5G network to send information out through the internet to the reporting portal and the InfiniGrid. And at InfiniGrid, that data is analyzed, it's monitored, it's made sure that everything is working at peak capacity. Within the reporting portal at the moment, we'll display all that information. Now, what's great about this is because it's 5G, it's super fast, low latency, but also the ability to send information back and forth. So mobile terminate is what we say. So normally if it's your phone and your phone makes, is essentially an IoT device, just like this is, makes calls out to the grid, to the cloud. So that's mobile originate. The interesting thing about mobile, about 5G is that it has the power to mobile terminate. So take information back in across the network. So when the information goes across over to the reporting portal, it's transferred with a token. That token is sent back to the XQ cloud platform with the identity and says, hey, is this information expired? Do I have the correct policies? Great, I do. Here's the key, decrypt it. So it's safe. Now, every packet of information that goes across this is kept secure by a different quantum safe key. So the advantage of that is, if someone breaks into the grid or the device itself, they only get that one packet of information. So you can see this as a one mobile power grid, but Nima is working on contracts for thousands within certain countries. So if he was managing 4,000 mobile power units within, let's say South Africa, even if one is compromised or one bit of information is compromised, this particular setup, this platform keeps the rest of the grid safe from attack. And that's a unique feature to our approach to security. If you are interested in exploring our platform, you can go to xqmessage.com, sign up for free, get an API code and some demo code, and get going. Love to see what you come up with. So why is this important, and what impact is smart energy and security going to have, right? So the ultra low latency that's applied by 5G and combine that with strong security, it's going to create the confidence to run mission critical applications that demand absolute reliability and responsiveness. This includes things like, life and death situations. We want to prevent sort of outages, things that happened in Texas recently. So the current advanced energy industry is worth about $1.3 trillion globally. The US government labels this as one of the 16 critical infrastructure sectors considered vital, absolutely vital. Its incapacity, and quote, its incapacity or destruction would have a debilitating effect on security, national economic security, and national public health and safety. So the government itself sees this not just as an economic engine, but as a public safety sort of source and center. So you think, is anybody really going to hack the grid? I mean, what's the benefit of that? I mean, well, they're willing to go after elections. Why not energy as well? So a Puerto Rican utility recently estimated that if someone were to tamper with the wireless smart meters, it could cost them up to $400 million per year. Recently, I think it was December, the solar winds attack, lots of publicity around that. Some of the things that may not have come out is that some of the victims there were also the US Department of Energy, the New York Power Authority, as well as 18,000 other total organizations. So there is risk here, and the impact could be catastrophic should something happen to the energy grid as a whole, the power system that's available, not just within the US, but globally. So it's not just the main grid. There are other areas and systems as well that have that are vulnerable, right? So say for instance, just renewable turbines, they're very easy to get into physically. After that, being able to hack a farm itself, they'll lose $30,000 of revenue per hour, and it's very easy to destroy the turbines totally as well. A malware attack in the Ukraine recently was a novel malware attack. I mean, that brought rolling blackouts to Kiev, bringing on complete darkness. I think this is the first example of a known malware attack against an electrical grid, which was successful. We look at like the other use cases that are available: smart grids, digitally enabled logistics, enhanced field operations, production optimization, drilling optimization, and automation. So beyond just smart grids, you can see how the other aspects of energy creation and energy management, being able to manage that data in both in a bidirectional fashion, knowing which parts of the logistics systems are available, knowing how your energy operations and some of the metering are functioning at any particular time are important. You can look at, if we take a simple example of like wellheads. Right now, the middle of Wyoming, it may take each wellhead may be 25, 50 miles apart. One individual can manage maybe 5 wellheads. If we're able to create a system where through 5G connectivity and other localized data management on those wellheads, a single operative might be able to manage 15 to 20 wellheads, and you can see how obviously there are economic benefits there. So if we look at just how IoT for enterprise, that market size is affected, because the smart energy needs resilience across autonomous vehicles, across agriculture, across manufacturing, construction, supply chain, and agriculture. Right now, we're looking at like about 9 billion devices that are out there right now. Within 5 years, it's going to grow to over 25 billion devices. We see there's an estimated GDP growth of between 1.2 trillion and 2 trillion by 2030. So there's an enormous economic impact, and specifically like within a few key verticals in the economy. As I said before, manufacturing, construction, and mining. The IoT market opportunities are such that energy and utilities are key here for real-time automation specifically. But without energy, you're not going to have the support of auto. The ability to support auto, healthcare, manufacturing, healthcare, and public safety. So these are the other key aspects of the economy that'll grow through IoT, and the proliferation are dependent on smart and resilient energy. And then we can see that 5G and IoT will transform every aspect of industry. Critical infrastructure is going to be vital to that. And some of the types of devices like NEMA and advanced renewable power that they're creating and bringing to the world have the opportunity to change people's lives globally, whether that's within education, public safety, transportation, manufacturing, and general energy resilience. Thank you very much. That's my presentation.
One comment I'd love your thought on is a number of the presenters before you, Andrew Dicker, Jose Casillas, and Sean really talked about the interconnection between different systems. So it's really smart energy connecting to smart transportation, connecting to digital agriculture. Could you make a comment on the importance of being able to do secure communications across different systems? Because a lot of people talk about security within a system. And I think what we're finding is cross-platform security or security from domain to domain is becoming a critical element. And if you could comment on, is that something you're seeing in all your projects? Just would love your thought on that.
Well, certainly, like the ability to have security within energy supports the basic functionality of autonomous manufacturing and other systems. But certainly, like, you would want autonomous or manufacturing to know if there was a problem with one energy system and be able to switch over to something else. That ability to communicate between the different systems across platform is going to be vital, and to do that securely, so that you wouldn't subject your various systems to the possibility of blackout and failure through one vulnerability in one system, allowing vulnerabilities in others as well.
Great. Thanks for that. We're lucky to have Dr. Magnuson from Texas A&M from the iTech Center. He spends all day worrying about reliability, not only for the state of Texas, but actually for America, with his support for Homeland Security, DHS. We're lucky to have Dr. Magnuson and Dr. Davis, who are going to talk about their perspective about the connectivity of energy systems, specifically related to what 5G can do to improve the overall management of these systems. So with that, Dr. Magnuson, if you would introduce yourself to the team, and Dr. Davis.
Actually, I think we're starting with Dr. Davis. So I'll switch it on over to her.
All right, Dr. Davis, you're online on the video. I think you're, okay, there you are, Dr. Davis. Thank you.
Okay, howdy. Yeah, so I'm Kate Davis with Texas A&M, and my role in this is I run a cyber physical power system test bed here at Texas A&M, and I'm also leading a project on cyber physical energy management system. So how do you do this? How do you create a next generation energy management system that's really cyber physical? And so really the key idea, and I feel like all of the panelists were like different musical instruments playing the same song or something. So it's like a symphony. So power systems are large scale nonlinear systems, and they're critical infrastructure for keeping the lights on. And as has already been, said in different ways, like I said, it's kind of like different instruments in the same song. Other critical infrastructure is highly dependent on electric power, and without power and energy, you can't do much. And so those of us in Texas, we really saw that this was true with the big winter storms and the outages that we had about 2 weeks ago. And with all of this, a major challenge in large-scale power system operations can really be summarized as the need to make good decisions. And what needs feed into these decisions are the needs for good data and the needs for good models. And the bottom line is that the system is already complicated. And this has been covered in different ways by the earlier panelists as well. But the challenge is even more complicated when you really look at what all is going on behind the scenes. And that's when we start looking at the communications and the cyber infrastructure. And so what has historically been overlooked in the electrical infrastructure is this interdependence on cyber. And it's really key, and especially going forward. And so this includes all of the smart devices like relays and remote terminal units, all the way up to the monitoring and the control networks that connect them and really govern power grid operations. And so part of the solution to how to address this is that we need to consider the system as a cyber physical interdependent system, and we have to avoid the tunnel vision of looking at the parts of the system independently without regard to how those parts interact. And so resilience requires coordination amongst and between a range of stakeholders on different scales. And we've seen this again in the outages that we had here in the past 2 weeks. We've seen just how complicated it is and how many stakeholders are involved. And this resilience also has to be done over the entire life cycle of an event. And so this figure on the slide is from the 2017 National Academy's report on grid resilience. And basically the idea is that we really need to innovate prior to an event, during an event, and after an event, as well as we need to close the loop to learn from these events about how to plan and operate the systems better. The way to have a scalable solution for improving power system security is that power system security needs to be done based on resilience. And so we just talked about resilience. And so to do this, you need to look at the data and the data flows in the system. And so this is a picture of an overview of the data flow pipeline in power systems from the field sensors all the way up to the systems and the applications and eventually back out to the operators. And so to secure power system operations, basically, it's really important to start by identifying where and how things can go wrong. And so we can do that by looking at the data flows from the field to the applications to control. And so this monitoring and control pipeline basically underlies all other applications and power systems. And so fortifying this layer is really key. And so, so why this is so important is if you think about where can things go wrong, it's basically at any point along this pipeline. And so you can kind of think about data as this common point of interdependence. And so if you look at what happens to the data going from the sensors to the applications to the field, then you have good insight on what you need to secure and how to protect the power system applications. So the solution is about better modeling and better situational awareness of what can affect resilient power system operation. And then you back into the cyber systems to see and defend those potential access paths. Okay, so this is a quote from the US Department of Energy's roadmap for securing the energy sector, and does a nice job of summarizing the state of things. And so what we're working on is we're working on this roadmap through our Cypress project. And so you can kind of read this statement, which is saying that reliable energy and power is the cornerstone of our economy, and it's critically important, and everything else depends on it. And so basically it's extremely important to protect against cyber attacks. And so this is a good roadmap. If you haven't had a chance to read it, I recommend reading the roadmap. And you can see that this motivates innovations in bringing together power systems and 5G that I will let Walt talk about next.
And I'm Dr. Walt Magnuson. I direct the Internet to Technology Evaluation Center. And we've been working for the last 10, 12 years in 4G and 5G technologies, working predominantly in the public safety sector, working with the FirstNet folks, and then more recently 5G and private networks as well. And realistically, I didn't know who Dr. Davis was probably about a year or so ago, and I was out there happily doing my 5G stuff, and she was out there happily doing her energy cybersecurity stuff. And then we kind of discovered each other when all of a sudden an opportunity came up to look at, well, how do we utilize 5G to manage energy? Well, really, to go ahead and do that, you really have to understand the differences between 4G and 5G. So what are kind of the pillars that 5G is built on? It's built on eMBB, high-speed broadband. Most of the stuff we've got right now is running, if you're running a 4G device, you might get 20, 30, 40 meg around in there somewhere, whereas basically 5G is going to take it up to a gigabit per second on existing frequencies, and more than 10 whoops, it's supposed to be gigabits on millimeter wave. So very, very, very high speeds. What does that mean? Be able to support things like 4K video and even 8K video and 16K video in the future. MMTC, massive IoT connections. Currently 4G networks kind of have limits as to how many IoT devices can be supported based on some of their addressing spaces and some of the parameters were built into 4G. 5G looked at it, and as was mentioned here in a previous session, I believe it was by Brian, we're going to be looking at quadrupling the amount of IoT going forward. So the 5G network has to be able to handle that. Network slicing, how do we go ahead and use software-defined networks to manage and secure the network slices? As was mentioned during one of the other earlier sessions, wouldn't it be great if we basically could share infrastructure? We could share the 5G network, and public safety was guaranteed that they would get what they need. Energy is guaranteed that they get what they need. Banking basically has got different requirements, but how do we manage what banking needs? So in essence, how do we go ahead and look at the applications, look at the requirements of the applications, and cut up the network to be able to support each of them? And then was also mentioned in one of the previous sections, there's mobile edge computer edge cloud. So how do I take the compute capabilities and run analytics out at the edge? Obviously we're not going to send everything into Google to really go ahead and do all computation. So how can I go ahead, or AWS or Microsoft, how can I go ahead and actually do the computation right where the cell site is for things that require very, very, very low latency? And by the way, I skipped that one, URLLC, ultra low reliable latency. The low latency part of it impacts things in a smart grid. Like, when you saw earlier, Andrew kind of was showing us the switching around the new grid being a loop instead of two separate threads. In order to be able to do that switching within the time parameters that are required, you're looking at 1 or 2 millisecond latency requirement to be able to do that. 5G can meet those kind of requirements, whereas previous technologies like 4G really could not. So something else has happened over the last year or two, and that's that the FCC has started to open up frequencies that allow end users to be able to build their own wireless networks as well. It would be great if we could 100% rely upon the big wireless service providers, AT&T, Verizon, T-Mobile, Sprint, and others, to be able to go ahead and meet all of our needs. But the reality is, for example, in a plant, for them to be able to provide saturation and penetration inside all areas of a plant to meet all those requirements is going to be very, very difficult. So this opens up opportunities. For private networks to be able to support specific areas where it needs augmentation, and the service providers to be able to provide support for the general public. So if you look at this diagram here, the two maroon clouds in there, maroon obviously is Texas A&M's color. So if you look at the Smart Grid Center, that's Dr. Davis' center, and that's where she's doing work with securing the smart grid. And that's done basically by utilizing fiber from utilities, by using zero trust architecture, technology, and stuff like that. In other words, a very closed mesh network. And that actually works very, very well when you're working in a world of generation of power and the transmission of power, where they have fiber pretty much in all the places that are important. Now I start getting into distribution. Now I start getting in, and even getting more intelligence into the home. Now I'm really looking at basically how do I go ahead and add those set factors or those elements to what we're doing. That's what I've got here in the red. And the only reason it's red with Verizon is because that's currently who we're working with on a project. We're currently connecting our labs at A&M into Verizon's labs up in Dallas. So in essence, how do I take a zero trust architecture of Verizon on their 5G network and a zero trust architecture of a private network? In this case here, it's the IPG 5G, which is A&M Smart Zone or 5G Zone. So how do I take those two networks and interconnect them so that they're both still utilizing still providing zero trust services, but yet it's two separate networks that are in different trust domains. So Dr. Davis and I are working on a proposal as we speak to go ahead and work through that problem of interconnecting these networks. There's a proposed project under the NSC. It was mentioned a couple times earlier, once by Sean, I believe, and once I think by Jose. So basically, those projects are looking at creating asking the question, how do I stimulate 5G adoption? How do I utilize things like the Internet 2 backbone, which is a research and education network that the US government has invested significant money in, that's managed and run under a 501(c) not-for-profit that's run by the leading universities in the United States. And how do I go ahead and utilize the cores of the 5G networks? And to let you know, basically, the core is the brains of the network. The core is the thing that manages all of the 5G and 4G infrastructure. Suffice it to say, they're very large and they're very expensive. So not every test bed is going to be able to manage and is going to want to manage and support their own cores. So how do we share them? How do we set it up to where a zone could be established in most any state, at most any campus, and could share the cores, but put in their own what is referred to as RAN, or the radio access network? That's the cell site itself, much smaller, much easier to manage, much less expensive. So how do I use the elements? How do I share the elements that are very costly, and then distribute the elements that are less costly? That project basically is labs across America, and it's a proposal that's just going forward now. And so the A&M iTech, the core we have there, we've been working with Jose and folks to go ahead and get the Puerto Rico 5G zone, 5G test bed connected up, whereas phase 1 would be connecting 4G core to the University of Puerto Rico. That mainly is just to establish the connectivity. It's easier to do in a 4G world. Phase 2 would take it to 5G non-standalone, which lets us use existing 5G technology that's being tested by the major wireless providers. And then phase 3 would basically be transition to the O-RAN technology that's evolving, which in essence is, again, a modification it's an enhancement to the way we build the RAN. How could we do stuff that's all virtualized and allow new entrants into the market? So that would be one of the focuses, I believe, of what the Puerto Rican 5G network would be. The labs across America is expected to expand out across a number of sites, a very significant number of sites across the United States, including Puerto Rico. But it's looking like at this time, there's a pretty good chance that the ITEC and the UPR zone in Puerto Rico would be the first one, very probably, to be able to take advantage of that connectivity.
I do have, one question. I mean, a lot of the work you were doing has to do with the information model on this. And I guess one question is, that's obviously lacking in 5G. Do you see that within 5G, we'll actually have a full-blown information model for what you're describing? Or do you see that by the time we sort it out, it'll show up in 6G? So it's a bit of a loaded question. One is on the development of standards. I know MITRE and Dr. Clancy is pushing for example, APIs on just being able to look at the software and being able to take hashes of the software to develop a risk score. But one of the issues is we might be too far into 5G. We might have to wait for 6G. So any thoughts from either of you on the emerging standards, or we need standards, and actually the timing? Do you see it coming into 5G, or do you see it spilling into 4G? Either of you, if you wanted to make a comment. Dr.
Kate, you want to take that?
Sure. I mean, I think that's a great question. And I think that's part of the research and something we're hoping to try to answer. In particular, with Walt mentioned, we're working on putting together a proposal for hopefully a project that would actually would address some of those things that you mentioned.
So Junaid, my part of the answer to that is that, I think how quickly we can get things done is often a function of how much money is being invested in that area of research. And if you look at the proposals that are coming out now from NSA, coming out from DOE, coming out from NSF, coming out from DOD, coming out from absolutely everybody. If I were to look at all of the areas of 5G, I would be willing to bet, now I haven't counted anything, but I would be willing to bet that there's way more effort going on in the 5G cybersecurity space than in any other space of 5G. So that being the case, you get enough people and you get enough good minds and enough good money behind it to be able to do the work. I think you can see a lot of stuff happen pretty quickly.
Great. Thanks to both of you for very actually in-depth presentation that, for our guests, this will be turned into online videos. You actually covered a lot of material very quickly. So again, thank you for both of you supporting this, and actually the great work both of you do on national security. As I mentioned before, Dr. Magnuson is actually one of our national leaders in terms of large-scale first responder networks. Dr. Modi is really one of America's experts in RF interference. And he actually is one of the leaders in understanding how interference happens, but more importantly, developing solutions around RF interference that are fully automated, that can happen in real time and are actually a foundational element. So we've had two presentations which are kind of foundational. One was Dr. Nima's presentation on power and portable power, which is a kind of brand new idea. And Dr. Modi is really going to talk to us about a completely new approach to RF and making it actually intelligent. So with that, Dr. Modi, if you could introduce yourself and tell us about some of the breakthroughs you're working with.
Hey, thank you, Junaid, and Invest Puerto Rico and everybody involved in the organization of this event. I'm really grateful to get the invitation and speak at this event. I really believe in this cause, in providing a safe energy resources across the United States and across the globe. I really was impressed with all the presentations that happened before me. So, this was a great learning experience as well. I did my PhD at Georgia Tech, and then I served as the vice chair and the chairman of the National Spectrum Consortium. In 2019, I started my own company called as Aeronaculus, and our aim is to create intelligent RF and networking from space to smart cities. So essentially, it covers the whole gamut. I've worked extensively in my past life on a few projects related to power grid and how, for example, any kind of cyber attack can disrupt it, and what do you need to do if you have to, start from or black start the network. And so, this is not entirely new to me, and it is really, really interesting how all these things in 5G can potentially come together. So in this particular slide, I'm just saying that so there are so many wide variety of applications that a grid has to cover. And power grid is not energy grid, right? It's in fact, it's a communications grid, because as our previous speaker, Andrew and Dr. Davis and Walt said, and even Dr. Nima, that when you actually have the power generation, the power actually is moving from the power plant through the transformers, through the relays, through the distribution substations and to your homes. But at every phase and every step, there's some sort of communication that is involved. And some of the latest things, for example, synchrophasers, as was mentioned previously, which is used for distribution and automation. The communication needs could span like 10 to hundreds of kilometers, and they might need like less than 20 milliseconds of latency if you really want to synchronize the grid, right, across and make sure that the power is flowing or there's a maximum power transfer. Or some applications like protective relays. So say if there's a failure in one part in a protective relay, you want to make sure that within 60 hertz is the electric cycle. And so 1 by 60 hertz is actually 16 milliseconds. As you can see, the protective relay, within 16 milliseconds, you have to convey to the next hop, which is on the relay, that you got to trip. Because if you don't trip, then you are destroying subsequent phases of your relays. And so in fact, all these communications is nothing but, or the power transfer or power grid is nothing but actually a communications grid, right? And so what is actually required is, for you to create a heterogeneous network optimization function, where you can optimize your network from generation to relay to distribution to smart cities. Now, one of the things that we are doing here is that we are actually working with Invest Puerto Rico and with Kurt at Celeris to actually bring one of the technologies, which is called as BIFAR, which uses unused television white spaces. As you know, television spectrum in UHF frequency is extremely good for propagation. And if you see over here in this slide, the distances that are involved, that kind of communications capability can play a huge role in smart grid and power grid communications as well. So we are working on a technology transfer where the manufacturer would be actually transferring the technology to Puerto Rico, and then the actual manufacturing will happen in Puerto Rico. So hopefully that happens, but we are really excited to be part of that process. So my company, Aeronaculus, actually is also working very closely with the Department of Defense. There's one project where we are working on where we are enabling spectrum sharing between 5G systems and high power radars. So for example, the AWACS radars, they have extremely high power. They can be operating anywhere. Typically, they operate from 2.7 to 3.7 gigahertz. And in fact, that is a prime spectrum for 5G. So globally, 3.1 to 4.2 gigahertz has been designated as a 5G spectrum. And that's an issue for the DoD because, while all these countries would be deploying, 5G devices, we still need to operate our radars and other critical resources that the United States has. And so how do you make that happen, right? So one of the things that we are working on is to basically develop technologies that will enable spectrum sharing between these high power radars and the 5G systems. And some of the critical things that we are bringing here is basically artificial intelligence and machine learning. The whole idea here is to complete the OODA loop, as we say, right? Observe, orient, decide, and act. You've got to observe what is going on in the environment. So in fact, one of the previous speakers, they also talked about that sensing is very important. And while you can sense the network, you can also sense the RF spectrum, figure out what's going on in the RF spectrum. You can have the fusion of the information, which is orienting your system and really figuring out what is happening. Then you decide, and then you make your 5G network act in a certain way. So this is one of the technologies that we would be developing at Aeronaculus. So this is another project that we are working on, and in fact, Junaid is collaborating with us as well. But this is with NASA, and Aeronaculus is part of the Moon mission and deep space missions, future deep space missions, including the Mars mission. And here, what we are doing is, in fact, optimizing the space network. Now, what NASA has, or the way they've architected their network is that it is a service-oriented architecture. So, they have different services. For example, the scientific services, the networking services, the detection services. One of the most important elements here is that the next Moon mission in 2024 will be on the far side of the Moon. So far, all the missions have been on the near side. And as you know, the Moon and the Earth, they are phase locked, right? So because they are phase locked, the Moon revolves and rotates at the same speed. And so you always see the same face of the Moon from the Earth. And all the missions, they have been so far on the near side. They basically created a dish antenna or put a dish antenna and then try to connect to the Earth. This time it's going to be on the far side. So in fact, what NASA has developed, or according to their concept of operations, they might actually have orbital relays. And these orbital relays will be going around the moon. And then whenever the orbital relay, it comes in line of sight with the moon base would send information to the relay, and then the relay will send that information back to the Earth. In fact, I do have a demonstration that I can show you, which was created by our folks at Aeronaculus. But the same concepts, right? The same service-oriented architecture, which is something which is a backbone, right, of 5G. Because as we know that 5G is not just a hardware architecture. It's not a communications or radio access network architecture. It's actually a network architecture. And 5G is all about software, because what is being done in 5G is to actually bring software all the way to the radio access network. Creating the centralized unit, the distributed unit, the radio unit, all that allows you to actually softwareize the whole stack of 5G. And so these are the same concepts that we are bringing to the space and to the deep space. So, as I said, the same concepts, right, that you have for the deep space as well as the 5G, we at Aeronaculus are bringing those same concepts to the smart grid as well. And, as I mentioned in my previous slide, that, the challenge with power grid is, first of all, distances. The distances are enormous. The latencies can range from less than 16 milliseconds, spanning for links that can span hundreds of kilometers. And so far, the approach that the grid operators have is that they actually either deploy very expensive optical fiber lines, say, for example, when they want to protect the relays, or they actually buy their own spectrum. And that is extremely, extremely expensive, because they are investing in the spectrum because they want to protect the relays. So new technologies like 5G and, for example, network slicing, you can actually create these architectures where you can provide guaranteed latencies, right? So Walt, in the previous speech, he talked about ultra reliable, low latency communications and other techniques which can be used to create these network slices that provide very specific guarantee of service for these applications, right? And so 5G is not just about quality of service, it's about quality of experience. And this is what we would be doing at Aeronaculus. Spectrum-aware intelligent RF is a cornerstone for autonomous management and orchestration, heterogeneous network optimization, as well as slicing. We are actually not just trying to do this where we are bringing Wi-Fi to Puerto Rico. So that's the plan, that we would be hopefully creating a manufacturing facility for Wi-Fi products in Puerto Rico, but also we'll be bringing 5G new radios. And so that would be a brand new radio and brand new technology, intelligent radio technology that we would like to build, my company. And we are really looking forward to working with you guys. This is a demonstration that we have, and this shows you how we are creating the architecture for the next moon mission in 2024. And in this particular moon mission, if you see, the moon base is on the far side. What NASA is going to have are the 3 orbital relays. So the 2 of them are in elliptical orbits. They're slightly oblique. And the third one is equatorial. And what NASA has is basically all these Earth stations, right? So they have Earth stations in friendly countries. Essentially, United States, you can see the Houston Mission Control Center. There's a Earth station in Chile. I unfortunately don't know Earth station in Puerto Rico, but they do have Earth station in Spain and Italy and Singapore. So basically, the technology that we are developing is that, first of all, based on the geometries and some deterministic approaches, just figure out which relay should be communicating with which Earth station. But not just that, we are actually optimizing every link based on the service that NASA desires. So say, for example, in case of supernova, which happens once in a lifetime, and it only lasts for 100 seconds. And, that's a holy grail, that you really can't miss a supernova event. So what we do is that's when the scientific service becomes an extremely important service for NASA. And what NASA is trying to do in 2024 is to actually also create a space telescope on the moon base. And so we would be, calibrating the entire, or configuring the entire network so that there's maximum data transfer from the moon base onto the Earth stations, so that none of the supernova event is basically missed, or none of packets are missed, right? So same thing goes when you have critical events, for example, launching or docking, those are critical events. Or say, for example, you might have some other events like flares and interference. And so the whole autonomous configuration of the network is something that we are doing at Aeronautics. So with that, I'd like to stop my presentation and see if we have any questions. Thanks.
Well, thanks, Dr. Modi. That's a fantastic presentation. Looking at that video and animation, it struck me that a lot of the problems you're solving are actually a generalized solution for autonomous vehicles moving through a smart city as they switch networks. Could you maybe spend just a minute talking about how algorithms in space can be used on the ground? And there's a theme here, which is, NASA produced a lot of technology out of the Apollo mission, which really, powered, the computer industrial revolution here in America. And now with 5G, we see NASA doing a lot of work there. Can you make any thought about any comments about the use of the space technology actually for 5G networks on the ground, just to make everything work together more properly?
Yeah. So, smart city, essentially the biggest problem in smart city is going to be millions of devices. Of course, 5G has created massive machine type of communications, but there are other competing technologies as well, right? So, you got Wi-Sun, which is IEEE 802.15.4. You have Wi-Fi, you have LoRa, and so many others, right, for massive machine type of communications and Wi-Fi. All of these will be competing for spectrum. And when you have millions of these devices, all competing for spectrum, it becomes a real challenge on how you manage those spectrum resources and network resources. It's a very difficult problem. And so this is one of, and in fact, what we are doing for NASA's moon mission is no different, because one thing that we cannot go wrong when it comes to space missions, because there's nobody if you go wrong, there's nobody going to go there, on an orbital relay circling around the moon 300,000 kilometers from the Earth to fix what's wrong, right? Because it's not a manned mission. And so the same thing goes for smart cities, where, if you have autonomous cars or other devices which are autonomous, then you got to configure them on the fly. And that's exactly what we hope to do.
Great. Well, thank you for a wonderful presentation. Thank you for your work on NASA. I'm sure that's ultra cool project to be a part of. And I'm sure we'll be seeing more of you in the near future.
Hi, everybody. So my name is Nicholas. I am the founder and CEO of Desgrid, which is a software company based in Puerto Rico. We provide the marketplace built on the decentralized ledger technology and a user application enabling all interactions with the microgrid. Electricity in Puerto Rico is the second most expensive in the United States and its territories. In addition, with an average of 12 electricity interruptions every month of 5 minutes each, and sometimes in much longer period of time at once, the grid is not reliable. Distributed energy resources such as microgrid are valid, sustainability alternatives in the different forms, but mostly meant for a single entity usage. A community microgrid is the version that we are enabling for entire communities. Starting with Puerto Rico, our objective is to drive successful communities by providing affordable access to reliable electricity for neighboring businesses to operate and families to function. So we designed these energy alternatives centered on three fundamental pillars: community first, then technology and regulation. Other microgrid strategies are focused on the technology part, meant for a defined ecosystem. A building, for instance, could generate electricity from solar panels and sell it to its tenants through a metering-based payment portal as part of the monthly rent. However, this approach can only work in this enclosed environment. It's a very different problematic if the building wants to sell its electricity to a third party. While the role of the regulator is fundamental to ensure just and reasonable rates to the community, the marketplace enables a transparent, fair, and competitive pricing discovery mechanism. The application handles all user interactions, including onboarding and payments on behalf of the microgrid. Community microgrid usually start with an anchor, such as a business or an association. Credit-worthy entities are able to leverage the quality of their balance sheet in raising the capital necessary to deploy the generation and storage assets. Then, an energy service company, also known as ESCO, deals with all matters related to the Energy Bureau of Puerto Rico. Finally, our solution focused on the marketplace and user application. While it represents an additional revenue stream for the company anchoring the microgrid, its social impact is positively unlimited. The market rate per time of use is combined with the reliability safeguard. We've designed the marketplace focusing on consumption behavior incentives to optimize demand response, ensuring refined coordination between non-dispatchable regeneration and consumption needs. This is critical for the performance of the ecosystem so that the recent Texas situation with thousands of dollars per kilowatt hour charges does not happen again. On the onboarding side, users register through our website. Then, once a local microgrid is deployed, consumers prepay their energy credits through their interface. Users, including the consumers, the anchor, the prosumer, and the regulator, can interact with the microgrid through their own interface. With community microgrids, local companies are effectively leading the growth of their local community. But these companies already are busy running their own business operation. They should not have to deal with any hassle, mostly on a sector they might not be familiar with. We believe that our turnkey solution gets them there to where they can most be engaged with their community. And this is supported by a flexible, reliable, and scalable energy ecosystem. So we make it happen in three major steps. First, we introduce the anchor to an energy service company registered in Puerto Rico that has the experience in developing community microgrid. Second, through our simulation model, we establish the best performing system, stress it under various conditions, and evaluate how much this system will cost. At the same time, we provide the company anchor with funding opportunities available through our local partnerships. Third, and lastly, we process all electricity prepayments, onboard users, and launch operation. Here is a typical community microgrid setup in Puerto Rico. First, a company or an association wants to become a microgrid anchor for its community. Second, a sponsor is created to secure ownership of all generation and storage assets to be deployed versus loan payment and equity. Third, an ESCO is designated to handle all matters related to the energy regulator, and Desgrid is contracted to provide the marketplace and handle users' interaction on behalf of the microgrid. Lastly, onboarding is done through Desgrid's website on the domains specifically allocated to the microgrid. Consumers prepay their energy credits and get physically connected to the microgrid. Prosumers enter their system specifications, get physically connected to the microgrid as well, and start selling their excess electricity to the community. Here, you can see an example of a community microgrid currently under development in the south of the island. The anchor is Industrial Chemicals Corp at the bottom left. Consecutive scaling phases are also represented on the map. This community microgrid is looking at using solar panels, batteries, and cogen as backup. It's also deploying its own standalone microgrid. The anchor of this community microgrid based in Tayaboa also controls the site, facilitating the asset deployment instead of having to rely upon hundreds of different rooftops, as well as the standalone grid. In this case, the sponsor and the ESCO are managed by the anchor and the former chairman of the Energy Bureau, bringing his invaluable experience in the process. Desgrid handles the marketplace and all users interface. So for anyone of the audience wishing to become an energy anchor for our communities, we need the energy data. It means electricity bills and the energy generation system specification. We crunch all those numbers into our model, and we can also help getting electricity bills from the community. The results you get are economics and social. For instance, how much this means in real dollar revenue, not just utility credits, but also the opportunity to engage with your community and be recognized as the leading force for successful growth in Puerto Rico. With that said, I thank you and look forward for any question.
Great, thanks for that. One of the interesting things in your presentation is I noticed the synergy with Dr. Nima's presentation of, he was creating, this micro power generators and distribution system. And I was wondering, we should probably have a future session where we have both of you together, but have you looked at these ideas of these newer generation technologies to bring down the cost of generation as you create these community microgrids?
So not yet, didn't have the chance, but this is definitely, the kind of aspect of developing the microgrid I'm looking after. While we control the software part of it, meaning the marketplace and the application, it always helps, to have better and cheaper technology for, each kilowatt hour produced. So anything that can help, if we could, we would go 100% renewable on the generation side. But if it makes more economic sense, to have an anchor to start using like a cogen, for instance, then this is where we're going to start.
Yeah, great. Well, thank you for that presentation. This was actually pretty new ideas we're seeing. So it's been great to have you.
Good afternoon. Yes, and thank you. By the way, I've been excited. I know I'm bringing up the tail end of the presentations, but I've been really kind of blown away by the discussions and presentations today. So by way of introduction, Ben Reisman, President and CEO, Battery Innovation Center in beautiful Southern Indiana. Also help run Energy Systems Network, which is in Central Indiana or in Indianapolis, Indiana. So just a real quick, I'll buzz through these quickly, but the BIC is a public-private nonprofit. Again, here in Indiana, we really focus around helping bring the entire industry together to help on the commercialization for our next generation energy storage system. So while battery is one of our focuses, ultimately we probably should be the Energy Innovation Center because we do focus on energy as a key. By that, we're trying to help catalyze those long innovation cycles that you normally see in industry. We also don't don't hold any patent rights. That's very unique in our space. So we do partner with a lot of national and academic labs as well. The one advantage to the BIC is we're focused on commercialization. So what you bring to us, you own. We do everything from low volume cell manufacturing to advanced testing. We do cells all the way to large scale systems. Literally, as I sit here today, we're doing some large scale fire testing on a large battery pack, inside of our building. So do some really cool stuff. So we've got a vehicle battery pack that we're starting on fire to see what happens and to share that data. And then we do a lot of research and consulting in this area from our expertise. Again, through our kind of historical, things we've looked at, one of the most recent focuses has been around a microgrid evaluation center. By way of background, so I'm an electrical engineer, but I'm also a master electrician by trade. That's what got me actually into electrical engineering. As I look at that, the grid has always been, we kind of always had the electricians and we've had the engineers, and they've really been, separated. We've obviously done deployments of lots of products, but in installing both personally and professionally, and through businesses, that I've been with on, everything from smart metering to at the time lead acid battery systems that were used for for backup to today, some of our advanced battery systems along with other storage. I've really recognized, again, it's more not the engineer in me, it's been the electrician in me, that there's been a lot of things missing in these deployments, as in the product actually works. There's nothing wrong with the product, and frankly, the solutions that it's supposed to solve, it's designed and capable of when we test it in the lab, but or when it's tested at the factory. But when you look at the scale deployments, we've noticed that the microgrids have been really disjointed. I mean, there's a lot of these that the work to get them deployed is very tough. The integrations that are required are very tough. We find that, again, folks are able to make it work by itself, but as you start to deploy it on the grid, the electricians and the operators, the generators, the end customers of these devices have really found that they aren't able to take advantage of those energy devices. And so we recognized an opportunity to really start to create a microgrid evaluation center where we could bring every piece and part of the scenario, including generation and distribution, wholesale, both behind the meter and in front of the meter, along with the lab capabilities, all into one place. So we opened within our facility a microgrid evaluation center that is, at the time, was one of the first that existed anywhere in the United States, and globally one of the few, where we actually have an ISO grid that is connected to our building. We have a 6.4 megawatt MISO grid that sits right outside our building. So we're on the Midwest Interconnect Service Organization, one of the largest by landmass here in the U.S. That is attached to a co-op that's here. As part of that, we also have solar and renewables that are online, that are connected into that grid. We are the only building that's on that 6.4 megawatt MISO node, and BIC has a 6 megawatt push-pull metering setup, the entire setup, transformers and the like, that allows us to operate on the grid and to use very, very large assets on the grid. But also we have our huge lab inside that has several megawatts of capability on the DC, so that we can play at every single level. So we can work AC side, we can work DC side, we can work smart meter and the like. So we put together this equipment in this environment initially to test out 5 energy storage and inverter systems. Since that time, have deployed, have got additional smart metering. We actually became the first MESA interoperability test center to look at how those storage assets work alongside solar assets and wind. And then we've really been looking at a lot of post-phase operations as well. So we're collaborating across the industry for these further developments. And so, the idea here is to create a plug-and-play environment. So you can bring in your smart meter, your microgrid, your community grid. You can bring in your home energy device. You can bring in smart monitoring. You can bring in controllers, any of that infrastructure, along with test equipment. So the ability, we had some of the very first high-power test equipment, as in we can simulate all the issues that, frankly, none of us want happening to the grid at all. Where we walk over to the switch today, and we want the light switch to go on. If we think about, the terrible events that happened in Puerto Rico, they were completely unplanned. Acts of God, in that line, the ability to simulate and actually showcase what's actually going on there, so that we can create and test and build capabilities that are sustainable to that they're resilient to that are capable of overcoming those events, and also helping with periphery support. So how do we, even in what we would like to, as an engineer, we use the phrase from an ISO perspective, call fail operational, and that's the key, is how do we create an environment where we can create an operational failure method. So as we fail and everything that's supposed to stop stops, there's still some method to operate. So the next phase of this, we were working on now getting into recognizing server and control. So as we set up, this hardware perspective, we've been looking and recognizing that, again, the hardware works, and we needed to validate that, there's compatible hardware. We've been recognizing, and hopefully others, that are on this call and some of our presenters as well are very familiar with that. We have a very centralized, grid historically, all over the world, not just here in the United States, but, Puerto Rico and Europe and, in Asia and everywhere else. It's very, very centralized. And we've been working towards how do we create a distributed and or a hybrid distributed system as well. And with that, we've got to have, control capabilities. Our standard SCADA systems that are out there today, and most of them are aged, frankly. Even the United States, we're very blessed by the fact that our grid is one of the youngest, frankly, except for, as we think about, Puerto Rico coming online with capabilities, hopeful that we can use that as again, a learning point for how do we do the grid right the next time around, and hopefully this new grid, the ability to get that, again, that fail operational and that resiliency in place. With that, the largest portion has been the operation and the controls. We need to have methods for all these different objects, all these different devices, as we get away from standard modes of, or not get away from standard modes of generation, as we hopefully hybridize standard modes of generation, how do we make those all interact, and how do we take best use of all their particular capabilities? When the wind doesn't blow, or frankly, when the wind blows and brings with it, ice and rain and freezes up our wind turbines, how do we take advantage of that with solar? And when that sun doesn't shine, how do we take advantage of traditional assets as well? And we're a firm believer that everything has to kind of work together. Coal has its place, natural gas has its place, nuclear has its place, hydro has its place. So how do we make them work together? How do we control those? How do we aggregate them? Within that, so we, control. Number two is also the safety perspective. So we have to keep in mind as we, historically, again, these centralized grids are very, very easy to attack. One, because of the age, but simply also because of the technology that's there, that's being deployed or that was deployed. And so when we're doing these new deployments and we're getting everything to be able to connect together, you obviously open yourself up to what could be significant cyber concerns. What could be a operational asset could be used as a threat asset, and we've already seen that. And that's unfortunate because we see one of the trade-offs to maybe considering renewables and this connected grid and all of our connected devices is now you open yourself up to cyber threats. And so that's where we recognize that there's an opportunity to also look at. So we got hardware, and then we've got controls, and we've got systems that can play together. We've got to have security, and then we've got to be able to vet all those together. With that, we've done some key cyber hackathons where we literally were some of the first that we know of to have people open source. So you bring your devices in, and we literally opened it to the world and actually gave an incentive to anyone in the world. So the hackers that are the young kids that are hacking in the middle of nowhere, nowhere world that have hacked into other places, we actually invited them to come and intentionally hack within our building and then hack those assets so we could actually learn what's going on, so that we could look at creating this cyber test house so that we have through that being able to expand scope and capabilities. So this was the initial microgrid that's there with several different assets. We actually had some portable assets that we've been testing. These are some disaster relief opportunities that become portable or semi-portable applications as well. So we started to really evaluate what's there. And coming out of that, there was work put towards a new protocol as we relate to these different control paradigms. How do we move from, again, that centralized, historically was centralized, and then we got, frankly, very decentralized, and now moving to distributed networks. So this paradigm shift, as we're bringing renewables, as we're rebuilding infrastructure, as we're adding new infrastructure, and frankly, bringing infrastructure for the first time, into underserved areas or what was maybe unpopulated areas that are now populated now in third world countries. How do we start to create this truly distributed network? Along this line is, we've got to think about a distributed intelligence. So we can't just say, okay, let's go break all this up and make it work. Make it work in unison. Instead of one parent controlling everything, now we have lots of parents that are running everything. Parents and children and teachers and principals that are and managers and the alike that are doing all this, we have to have an intelligence about it. So this multi-layered, federated architecture that supports the active coordination between all those multiple devices and systems, but ultimately, again, to solve a common problem, which is our energy. How we produce our energy, how we distribute our energy, how we get our energy, how we measure our energy, and again, how we have resilience to our energy. And there's all the underlying things of cost and accountability and future resiliency and the like. So as we kind of talk through this, how do we make sure that we frame that around capability, and then looking at the differences over traditional approaches. So we can stacking up business cases, enable that edge interoperability. This is where 5G and others come alike. So how do we take advantage of even emerging technologies that have been used in other industries? So 5G has historically been used for other types of communication. Well, not historically. It's been more for for general communications. But with some of the capabilities that exist, some of the security capabilities that exist, some of the bandwidth capabilities that exist, there's keen advantages for looping 5G into our control. So what has historically been centralized wired systems are now becoming those hybrid distributed wireless systems in a lot of ways. And not only does that provide us a different communication method, but frankly, it provides us redundancy. And that's, again, if we think about this as wires get broken and disconnected, there are ways through wireless to overcome some of that, and vice versa. Times where we have wireless that can go down, we still got to have that backstop of wired. So with that, this OpenFMB, which stands for Field Message Bus, was put together, and this is really a way to go out and create the easiest way to say it. And maybe we don't have any automotive folks on the phone, and apologies. That's also one of my backgrounds, is coming heavily from automotive too. So I had the grid, and I've had both transport and both transport and grid is basically CAN language. So this is the way where we can help historic assets and new assets, and this is everything from, again, smart meters to coal production to SCADA systems and alike, to actually have a common method to be able to communicate with each other for critical work, for daily work, to also control each other for everyday capabilities, but also provide a common platform. So think of this as a way for us to all talk one language. And I think I said in a previous session to somebody, I said for us all to talk English or something. It's like, wait, that's right. Maybe that's wrong. English may not be the best language. So how do we create a language that's best for the grid to use? So you can jump to the next one. This is just kind of the framework in my final slide of how you see this field message bus framework is coming about. And I'll be honest, this has really been piloted in the US and is starting to come about in some key areas here, and is being proposed for some of the devices that are actually going into Puerto Rico and actually in other places as well. So what you're seeing here, you can kind of see within all the layers, from your endpoints to your lower tier nodes to your middle tier to your upper tier, which is, again, everything from your utility to your distributor to your wholesale to your provider to the end customer and the end monitoring, a way to layer the OpenFMB protocol to be able to aggregate that information and to hopefully best use those networks. So this is a way to tie historic, and again, back to the car analogy, there's some things inside of a car that haven't changed, but by connecting a smart device to it, or connecting an ability to get messaging to it, and from it, for it to be able to generate or to be able to take its data and send it elsewhere and use it, we can take historic devices and connect them to our existing. So even in like autonomous vehicles today, that CAN protocol and that common platform language is enabling them to put more and more capability on board. And like I said, with this, it's also, there's a keen understanding towards that we must have cybersecurity here. So this gives us another method, and specifically, again, on historic devices, this gives us a method that if we have bad actors or threat vectors that may have been there before. This gives us a method to actually check those out. So this is the, this second or third level of checkout. It's kind of like today you have your two-factor verification. A lot of these grid assets today didn't even have a single factor of verification, and there are a bunch of critical assets. We have, unfortunately, personally as an engineer and as a electrician, I know of even some assets locally here in Indiana that simply a kid with a computer and internet access could frankly attack and shut them down, because they have no verification step, no single step that's there at all. So OpenFMB, this protocol is at least giving them to have single factor verification, and ultimately what you'll see is a way for us through the other tiers to create multi-factor identification and to have cross-factor identification as well. So with that, I'll end out, but yeah, I appreciate a chance to discuss kind of what we're doing with OpenFMB and how that's kind of grown out of our grid network.
So Ben, I'm going to put you on the spot. Given your expertise in control systems, would first love any thoughts on what happened in Texas, but more importantly, what we can learn from that as a learning event. So, you're probably closer to it. I mean, I'm also physically closer than most of us. For us non-experts, it was very hard to understand how such a massive failure happened. So again, would love your thought on what happened, and more to what should we do so it doesn't happen again, given the work you're doing in this area.
So I'll probably put myself on a stake with a few people. Welcome to get a hold of me afterwards. And it would be a long answer, so I'm going to try to summarize it. I've actually, discussed this and, talked with folks that are there, plus, companies that are interacting, suppliers that were a part of that, friends and family that are boots on the ground there as well. So I would say I do feel blessed or lucky that I get to see, at least I was lucky enough to see almost every way that it impacts people, all the way to the people that, were directly, dare I say, responsible, but were, actionable to it. Several things. One, frankly, it was a shift in what we wanted to do on the grid that was not well planned and well architected. And so, there's with that the reasons. There is, regulation that is good. There is over-regulation with misunderstanding and miseducation and misdeployment that caused us to make some changes there that we didn't fully calculate that future concept. And so we said we want the future, but we didn't say what do we do with the future. That's number one. And number two is to that planning was what are we doing to identify our gaps as we move from traditional, as they were moving and have moved for a while now, from some traditional assets over to non-traditional assets with wind. They opened some gaps by doing that. And again, that's just the nature of selecting that technology. There's nothing wrong with that. You just have to know in that infrastructure that, hey, I took out maybe what was fits nearly all solutions, but I've got a couple things I don't like about it. I put in this new solution. Oh, by the way, now I just, in my DFEMA, I just opened up my risk category significantly, and I opened up exposure to events that could occur even if we didn't think they were highly probable. We probably should have gone through that. So, is quickness to do that. Number three was actually planning again, but it was recognizing what was coming and looking at that. What were we doing to bring capabilities online? So there are some emergency assets that were available, and we missed out on the opportunity to put those online. I know some of that is also because of fines and other issues. Again, getting back to regulation and politics that was related to it. There was, decisions that may or may not have been made based on, are we going to get in trouble for trying to bring those assets back online? Lastly, it would be, again, just an overall reaction to that is there was a long time ago, a very centralized there is a, hybrid grid within Texas, but they are kind of decentralized from a lot of other folks. And I know that's a broader decision than where I'm at today. But as I think about it, them being disconnected from others also gave the chance for a neighbor to provide as well. And the best analogy I can use in all of this is, somebody had has got has got their net neutral house, and they've got, their ability for the grid out there, but they know if they turn it on, if they turn on the grid, I'm gonna have to pay a fee for that. They've got a backup generator, and if I do that backup generator, it has its things as well. And we basically failed on all that. That we're counting on one of our technologies to work. We didn't run to our secondary or what was our historical technologies because of a lot of different reasons. And then because we're disconnected from our neighbor, we had no way to take advantage and go over to our neighbor and be like, hey neighbor, can you help me out here? Like this is already starting to get bad. Is there some way that you can provide me some emergency and ancillary services? So unfortunately, it's a multifaceted problem, and I hate the fact that it's blamed on wind turbines. I hate the fact that it's blamed on coal and others, that they caused this and they should have got away from that sooner. It's not a one size fits all. That's the problem. It's it's a diamond. What it takes a diamond to shine and to look well for people is very much the solutions we have. They need to be multifaceted. They need to be hybrid. They need to be distributed. They need to have the ability to be connected in key areas and be specifically selected for their assets and capability there. We always use the kind of, I posted on the chat earlier, it's got to be that sustainable, responsible, manageable, accountable, growable, and future-proof. And we missed a lot of those categories in Texas, and that's everybody's fault. So,
actually,
Joanne,
do you that insight?
Do you mind if I add my 2 cents?
Oh, please.
Yeah. So sorry. So everything that Ben was saying is like very on point, and this is very the complexities that basically could be solved so that problem gradually gets eliminated. But for people to actually have a visual of what happened, I'm pretty sure everybody saw the headlines of some of these folks over there in Texas that paid tens of thousands of dollars of electricity bill. And it's not because they were actually running like an entire manufacturing company or anything like that. It's just like a regular home. It's just that the ESCOT at that point was completely down. The marketplace, which is not really a marketplace, but it's more like a centralized system where those generation capacities basically are putting their prices together so that it's reflected on the consumption side. So at some point, because there was no generation anymore, rate went through the roof, and somebody you're trying to basically hit up like something at home would be basically hitting up like an hour at $5,000.
Yeah.
And the main problem is the total disconnect between central utilities and the consumers, because central utilities have always relied upon their ability to be capable of ensuring the reliability of the operation. And they always put the disconnect with the consumer, whereas the consumer should be at the center of that. But to put the consumer at the center of that, you need to create that connect. And you need to incentivize the consumer to, hey, don't consume right now. That's gonna be so expensive, you don't want to do that. And if you help, we're actually gonna pay you. And it can also mean that what Ben was saying is if the neighbor has, assets deployed, then the neighbor can provide electricity, get paid for it in real dollars, not utility, metering credits, and provide the reliability to the grid. So that was my 2 cents.
Nico, Nico, I agree with that, by the way. Sorry, I was going to say, I agree. That's actually probably the root of the problem is who's the customer and what do we need and how do we get customer centric? I noted that in one earlier is really energy needs to be, I hate one size fits all. As a big guy, I even hate when I buy a one size fits all t-shirt or hat because it doesn't even fit me. And I'm like, wait a second, I thought this was one size fits all. I think it's important that each county, each region, each state, each providence, as we break those down at a macro level, you really got to look at the macro level because even for us to look at what works here in southern Indiana and, here in literally rural Indiana, we're not third world, but we're very rural, is far different than what it is in Indianapolis. And I can assure you it's far different than rural Puerto Rico or big population Puerto Rico. So let's make sure, I think you hit the point, Nico, which is how do we get it customer-centric, application-centric, and make sure that we're doing the proper application versus just trying to take the rubber stamp to every problem.
Exactly. It's about refining the coordination between demand response.
Thank you to all the speakers. It was such a fascinating, there was a lot in this topic, but it was really fascinating. And I want to also call out Apurva, who's not on the call. I know distinctly, I heard him saying he's moving to Puerto Rico. Yay. The other part of the response to your question is, I want to say that this is such a critical issue. In fact, I consider this the most critical issue that Puerto Rico will face. And it's not just related to our energy grid. It's this technology deployment in a practical way on every level of business to make businesses more competitive. And so it applies. And in fact, one of the primary areas of focus that we want to concentrate on the island is around the manufacturing of pharmaceutical and medical devices, which is a huge industry on the island, and logistics around that, which is going to be really dictated by distribution channels and all the recent executive orders. And the pandemic has really shown us that it's not about being really smart and inventing things. It's about then how do you distribute it and apply it. So putting it into the COVID, it's not about creating good vaccines. It's about actually getting them into people's arms. And so I think that's that's my very simplified language of what I think is the basis behind all of these discussions. And so, you know, I've had multiple people throughout the course of this webinar today who have texted me and said, wow, we need to have more conversations. We need to have another session because sessions like this bring up as many questions as they answer. But getting back to, again, that core of what's in it for business and what's in it for businesses, we're heading into an information economy structure. We've already well gone on that journey, and there just won't be a way for a region to remain competitive unless they look forward to these really data management systems for every element of how they manufacture, how they produce, how they use, how they distribute. There's a web site called you just have to Google Puerto Rico 5G Zone, and you'll come up with information on the zone. You can either become a corporate sponsor of the 5G zone. I think there's some pillar positions for entities that would like to be involved in that transition or transformation of the island through this facility. And then there's also memberships for companies to be able to participate in using the connection that Walt talked about into the core at Texas A&M. And then there's kind of a third component, which is the most important, is this research component. And so really encouraging people to become part of the network and help us as in each of the regions that has started on this process starts to identify their challenge questions from an economic perspective, and then how to share information and then how to advance that with other networks throughout the country. Great. So Puerto Rico 5G Zone.